Good morning, everybody. This is lesson number 1 on solving absolute value equations. The first thing we need to bring up is it is normal and we should expect an absolute value equation to have 2 solutions. That doesn't happen every time. There's also a possibility of 1 solution, and there's also a possibility of no solutions. So that's what I'll be demonstrating in the next few examples. We're going to start simple with simply absolute value of x is equal to 7. The graphing behind it is that we're looking at the absolute value graph, the mother graph, which by now you know is a V, and we're seeing where that graph intersects the line y equals 7. We're seeing when this graph's height is 7. So if I graph a horizontal line at height 7, we have a flat or horizontal line, and can you see that this line intersects the absolute value of x in 2 different spots? So this is a perfect example of when an absolute value equation should have 2 solutions. You do not have to complete this graph every time, but I want you to understand what we're actually doing and finding. When we're doing the algebra behind it, you need to separate this equation into 2 equations. Make sure you remove the absolute values as you do this step. If what's inside is equal to 7, we should have a solution. I put the word or down because if what's inside is equal to -7, we also have a solution. It's very easy to check these answers by plugging them in. And since there are 2 solutions, I'm going to use squiggly brackets, and I'm going to write -7, comma, +7 to make sure the teacher knows that I know that there's 2 solutions. Let's move on. This time, absolute value of x is equal to -6. Looking at it graphically, we have the same absolute value of x. There's our v. That's the mother graph. And if I graph the line y equals -6, -6 is a horizontal line down low. Can you see that this absolute value graph and this line never intersect each other? So when you have the absolute value of something equaling a negative number, can you see that there should be no solution? In other words, this left side has to be 0 or bigger. And this right side is clearly negative. So how can something that's positive be equal to something that's negative? So there's not really any work to show. I'm just going to simply state that there is no solution. In math books, you'll see a 0 with a slash through it, and that mathematically means no solution. But I'd say on a multiple choice test, you'll see this. And so make sure that you know that no solution, the symbol, and the words no solution mean the same thing. Okay, let's go on to example 3. This one's slightly trickier because notice the absolute value isn't by itself yet. When you're solving absolute value equations, it's very important for the absolute value part of the equation to be isolated. That means by itself. So we're not going to divide by 2 here. Our first goal is to get the absolute value portion by itself. And that's done by adding 3 to both sides of the equation. So when I do that, the -3 and 3 cancel, and I get absolute value of 2x equaling 12. Now we're to the point that we were on the last 2 problems. I'm going to take what's inside and equal it to 12, and I'm also going to equal it to -12. Notice the number on the right is positive, so we should be getting solutions. What's inside could equal 12, or what's inside could equal -12. These are 2 very simple equations to solve. I'm simply going to divide by 2 on both of them to isolate x. Here I'm getting 6, here I'm getting -6, and so our 2 solutions are -6 and +6. This is a normal absolute value equation. Okay, let's get fancier. Our first step needs to be to isolate the absolute value. So can you see that adding 9 to both sides is what we need to do? Add 9. If you don't add 9 first, this is going to be rough. We now have absolute value of x plus 3 equaling +4. Once your absolute value is by itself and you have a positive number on the right side, you must write two separate equations down. This is the most important part. If what's inside is equal to 4, we have a solution. Or if what's inside is equal to -4, we would also have a solution. So you have to solve both of these problems independently. These two answers won't be opposites of each other like the problems before, so be very careful. If I subtract 3 from both sides, I get +1. Here, if I subtract 3 from both sides, I don't get -1. That's a very common mistake. Be very careful. -4 minus 3 is actually -7, isn't it? So double check those with your calculator. The two answers we're getting here are -7, +1. Okay, example 5. First step must be, think about it in your mind, we have to isolate the absolute value. So to get the absolute value portion of the equation by itself, I need to subtract 8 from both sides. The absolute values are still there. The number on the right side is -7. So I'll pause for a moment. Do you think we're going to get solutions for this problem, yes or no? We have an absolute value equaling a negative number. They'll never have solutions. So I don't even do any work from this point forward. I'm just going to state there is no solution. If the absolute value portion is by itself and you have a negative number on the right side, we will not get solutions. All right, 3 more. Number 6. Step 1, get the absolute value by itself. Subtract 3 from both sides. That gives us absolute value of 4x plus 5 equaling 0. Well, that's different, right? It's when we get to this point when we normally write two equations down, right? So here I have 4x plus 5 equals 0, and then I would normally write 4x plus 5 equals negative that number. I'm going to write -0, but this feels funny because isn't 0 and -0 exactly the same thing? So aren't these two equations actually identical? And so if I solve both of them for x, I should get the same answer, huh? So remember, absolute value equations can have two solutions, no solution, or maybe with a problem like this, only one solution. If I were to subtract 5 from both sides, I get 4x equals -5. And if I divide both sides by 4, I now get the only solution of -5 over 4. That's a good way to express our answer, a unique solution for an absolute value problem. This doesn't happen often, but it does happen. 2 more, and then you'll be set for homework number 1. To isolate the absolute value, I'm going to add 3 to both sides. And now that the absolute value is by itself, I switch to 2 equations just like the other problems. And now I solve both of the equations by multiplying by 4. If I multiply through by 4 here, and I multiply through by 4 here, I will get x equaling 44. And here, if I multiply through, I will get x equaling -44. It's a good idea to put these in the squiggly brackets like I've been showing, but in the interest of time, I'm going to go straight to problem 8. All right. We need to get the absolute value portion of this equation by itself. And so to get that by itself, a lot of students think divide by a fraction, divide by -1/3. And that is true, but there's a better way to think about it. Instead of dividing by -1/3, let's think multiply by -3. If I multiply by -3, these two multiply together to give us 1, which gives us our absolute value of x minus 9 by itself, and that's very neat and clean. The number on the right is 30. So now we're to that point where I have to write my 2 equations down. We're going to get 2 solutions. The number on the right is positive, isn't it? So therefore, remove the absolute values. X minus 9 could equal 30, or x minus 9 could equal negative 30. To finish this off, let's add 9. Add 9. I'm solving them both simultaneously. This gives me x equals 39. And this gives me x equals, oh my goodness, doing this in my head, negative 30 plus 9. I think that is negative 21. Notice that these numbers are not opposites of each other. That only happens on the simplest problems. So a good final answer here would be negative 21, positive 39, and that ends our video number 1. Good luck.